All right, so let's go ahead and talk about inverse functions. So this is going to be a really good segue into exponentials and logarithmic functions. So this is what an inverse function does. So, and this should be kind of familiar for trig functions, because with trig functions, you probably had f of x equals sine of x. So then you also found like f inverse of x is just the arc sine of x, or sometimes you can also call it sine inverse. Kind of the same exact thing. So let's go ahead and talk about a little bit about inverses. So if I'm given a function f of x, we represent its inverse as f inverse, so not f to the negative 1. So this f inverse does not mean 1 over f of x. Please don't do that. That's not equal to, okay? Not true. Okay? So inverses kind of undo themselves. So in other words, if I were to take f inverse and compose it, so if I plug in the function itself with its inverse, what happens is that you actually end up getting the x value back. So imagine that you're taking the x value and switching it with the y value, and then if you put the y value back into the x value, you're going to get the back the x. So these inverse functions, basically what they do, they kind of undo themselves. So they are undoing. All right. So a lot of them are pretty straightforward. So an inverse function is a function for which the input of the original function becomes the output of the inverse function, and the output of the original function becomes the input of the original function. So in other words, the x becomes the y, and the y becomes the x. That's kind of what an inverse function does. So let's just give an example. So if I know f of 2 is 5, then what is f inverse of 5? Well, here your x is going to be your y. So x is our input, our output was the y. Now y is going to go in here, so our output will be our x. So f inverse of 5 should equal 2. So imagine that they're kind of swapping each other. So what do you think this is? If I know f inverse is negative 4, f inverse of negative 4 is negative 100, then what would f of negative 100 be? Well, because they're inverses, this one should be negative 4. So you're just kind of swapping it. All right. What about this guy? So if I know y equals 4x and y equals 1/4, these guys are clearly inverses functions because you can see this one is being multiplied by 4, this one's being divided by 4. So you're kind of undoing what you're inputting. So how do we show that they're inverse functions? Well, one way to do it is using this definition. So composing it and showing that it equals x. So one way that to do it is to plug in the inverse function into the function itself, and you should get x. Or you could do the other way around, put the inverse inside of, and then put the function inside of it, and you should get an x. If this is true, either or, then you can get, then you know that they're functions, inverse functions. So let's say this is, I'm going to call this f of x equals 4x, and I'm going to call the other guy f inverse. So what I'm going to do, I'm going to plug in f inverse into f. I'm going to plug in f inverse in here. So here our f is 4, and then in the x, what I'm going to plug in is the 1/4. You can see that the 4 and the 1/4 cancel out, so you just get x. So you still get the, so therefore they're inverses. So they are inverses. You could have also done the other way around. So you could have done f inverse and inside plug in f of x. So in other words, plug in 1/4, and in that x, plug in that 4x. And you can see that they still cancel out and you still get x. So you still get that other way around. So you can either use this one or that one. It doesn't really matter. It'll give you the same answer. So let's show this next example. So we have f of x equals 1 over x plus 2, and g of x is 1 over x minus 2. Are these guys inverse functions? Well, let's see. So remember that we can just plug in one function into the other one, and you should get x. So here, my f is 1 over x plus 2. So I'm going to have x plus 2. And in that x, I'm going to plug in the g of x, which is 1 over x minus 2. So you're going to have 1 over x minus 2 plus 2. These guys cancel out, and you get 1 over x. So this is just 1 divided by 1 over x, which is 1. Change the division to a multiplication and flip the x, and you get x. So they are inverses. So all you got to do to check whether two things are inverses is just plug in one into the other. And I'll leave it as an exercise that you can check g of f of x. And you can see that that's also going to give me x. So you can check this on your own. Okay. All right. So let's talk about one-to-one functions, because this is super important. So one-to-one function. So a function is one-to-one if x is in the domain. X in the domain has exactly one y in the range. So this is a little different than what a function was, because a function, basically what a function says is that every x has exactly one y. Okay, so you have an x and they have one y. When something is one-to-one, what that means is that every x has a unique y. So in other words, two x's cannot have the same y. So basically, if I have x equals 3 and y equals 4, then that means I cannot use 4 anymore for y. So for x equals 7, for example, it cannot equal 4. Okay, it has to be something else. So 4 is already taken. So y can equal 5, for example. But now that I have 5, it cannot, 5 is already excluded. So there's only one unique y for every x. Where a function, you have an x, every x has one y. But a function can have, so for example, for a function, x equals 3 and y and x equals 7, they can still have the same y value, and it'll still be a function. Okay? So to test kind of whether a function is one-to-one, we use a different type of test. We use the horizontal line test. Okay? So if the horizontal line passes through the graph more than once, then the function is not one-to-one. So it should only pass one time. Okay? So let's try out a couple of examples. So which of the following graphs are one-to-one? So one thing that you can do is that you can use the horizontal line test. And you can see that it's only passing the line only once. So this one is definitely one-to-one. What about this guy? This guy looks like a sine graph. You can see clearly that if I do one horizontal line, you have multiple values. So this one is not one-to-one. You can only have one unique y. So for this guy, there's only one. It should only be one unique. So this one's not one-to-one. What about this guy, the square root function? Well, you can see this guy is good. So this guy's going to be one-to-one. And what about this parabola? Well, you can see that this parabola actually goes to two different values. So this one's not one-to-one. Okay, because you see that you have a y value, you have two x values. So there's two x values for one y value. Okay, so this one's not one-to-one. All right, so we've got into this one. So if a function is one-to-one, it will have an inverse. So an inverse will exist. Inverse exists. Now the question is, how do you find this inverse? So all we got to do is just follow these steps. So the first thing is you got to make sure that the f is 1 to 1. We're going to change our x's and our y's. Then we're going to solve for y, and then replace y with f inverse. Okay? So here's another fact. So the range of the function f of x is the domain of the inverse. And the domain of f of x is the range of f inverse. So we know that f of x has a domain and range. And we also know that f inverse will also have a domain and range. Okay, so what this means is that the domain of f is the range of f inverse. And the range of f is the domain of f inverse. So this is really cool because we've been talking about domain, and finding domain is really easy. Finding the range is a little hard. So one way that we can find the range is like if we can find f inverse, then whatever the domain of f inverse is, that will be the range of f. So that's going to be something really cool that we can work with to be able to solve domain and range. So in the next video, what I'm going to do is we're going to do a couple of examples to find the domain and the range of various problems.